All right, guys, here we are. We're in doing algebraic proofs, and I got a little bit of help for you guys on the screen right here. I'm trying to tell you, use this screen that has all these properties in it. Use it, use it, use it, use it, because that's really the only way to get this stuff right. So, well, now we'll practice these problems in class. So this is just going to be a brief lesson on how to do it. All right. So when we're talking about proofs, that means proving the why is it okay to make the steps you made, and proving why is it okay to say if this then that. All right, and that's where our all those conditional statements and biconditional statements came in and all those things. So now we're going to apply it to math. So let's do something basic that we've done before, and let's solve an equation. The equation is -5 equals 3n plus 1. Okay, now how do I know it's okay? All right, when you think of justification, think of why is this okay to do or okay to say. So why is it okay to say -5 equals 3n plus 1? Well, that's because I gave that to you. All right, and so you're just going to call that given. You're going to say given. Okay. So now how do we go about solving this thing? Well, most of you should know that to solve this, you'll subtract 1 from both sides. Okay. Now, I'm not asking why we did this, okay, because that would be inverse operations. But I'm saying, why is it okay to do this? Why is this statement still right after we do this? Well, because since we did it on one side, we did it to the other. And so that was our subtraction property of equality. Subtraction property of equality, which just says this equation is still okay because when I subtract it from one side, I also did it to the other, and that's why this is still okay. Subtraction property of equality. What do you get after you do that? We'll see -5 minus 1. Well, that's -6 here equals, and those cancel out, so that's 3 in there. All right. Why is it okay to write this as this? Well, we're just simplifying. We're just simplifying what we've already done. Okay. And now you guys remember, you guys can. This is a video, so you guys, if I feel like I'm going fast, if it feels like I'm going fast, you can replay it. You could slow it down. You can do all kinds of things with the little module in there. So um, have at that if you need it. All right. So what's the next thing we would do? Well, we would see this 3 times n. I need the n by itself, so I'm going to divide by 3 on both sides. Divide by 3. Okay. So if I divide on both sides, hey, look at that. There's a division property of equality for that. Okay, so that's what I'll write down. I divided, and that's okay to do because of the division property of equality. All right. And then after you divide it, you get -2 on this side equals n on that side. And that's us just simplifying what we've done. Okay. And then finally, last thing, -2 equals n. I actually like to write it the other way around. I like to have my variable on the left and my number on the right. All right, now why am I allowed to do that? Well, look at this right here. They did it. Okay, so that is the symmetric property of equality. I switched it around because of the symmetric property of equality. All right, and these are the things that were in your flashcards, I do believe, on the Quizlet I gave you and all that stuff. And like I said, you'll need those things in order to do this. All right, so we're going to look at another problem. I think I did that in record time. So let's do another problem right now. Okay, so now let's make it look a little bit more geometry, Solving an equation in geometry. So here's our statement side once again, our justification side. Okay, and how do we start this? Well, we'll start this the way I've told you guys before. You need to say that KL plus plus LM is going to equal the whole thing, KM. All right. You may say, well, how on earth do we know that? Well, there's something that you guys did before called the segment addition postulate. Segment addition postulate. I told you the name before, but you never really had to care about the name, just you had to care about what to do. Well, now you got to care about the name. Okay, so that's what it's called, the segment addition postulate. So once you do the segment addition postulate, well, let's plug things in. We're going to take 5x minus 4 equals x plus 3. Well, I'm doing this wrong. Sorry. Let me do this again. Let's do x plus 3 plus 2x minus 1 equals 5x minus 4. How did we do that? How did we get that? Well, all we did was we substituted values in. That's all. So that would be the substitution. And I'm going to say POE. All right. That just means property of equality, okay? So our next step would be what? Well, obviously we'll combine some like terms. So this is going to be 3x on this side plus 2 on this side equals 5x minus 4. And once again, why is it okay that we do that? That's just simplifying what we've already had. All we did was simplify, right? All right, and then let's go ahead and do a little math. So we'll subtract 3x from both sides. Okay, and why is that okay? Well, we're gonna end up with 2 equals 2x minus 4. Now that's okay to do because of the subtraction property of equality. And why is it okay to write it like this? Well, we just simplified what we did. Okay, and we're almost done. Hopefully you can see that we would add 4 to both sides, and you're like, why is that okay? Well, that's because the addition property of equality. Addition, POE. All right, and then after you do that, you end up with 6 equals 2x. And I think you guys see where this is going with this. We simplified to get that. A couple more steps. Let's divide by 2 on both sides. Why is that okay? It's okay because of the division property of equality, POE. And then we end up with 3 equals x, and that was just from us simplifying. And then once again, if I wanted to switch it around, I could say x equals 3, and that's because of the symmetric property of equality. And there you go.